Again, let me take you through the partial differential equations, the PDEs. Rule number 2, elimination by arbitrary function. Okay.
Example 1. Umeambiwa form a PDE equation by eliminating the arbitrary function from. Umepewa an example. This is an arbitrary function of, let us use x plus y plus z. Then we have x square plus y square, maybe minus z square. It's equivalent to 0. So ukaambiwa form a PDE by eliminating the arbitrary function. So solution, kitu ya kwanza unafaa kujua the notations. We have partial z, partial x inatupea p, then we have partial z, partial y inafaa kutupea q. So hizi vitu ndio unafaa kujua kwa fingertips, kama inasema yes, fingertips. Now our solution for this equation. So the first thing you must know in this equation, you must identify your v, u and v. So our u will be this part, then our v will be this part. So this is our u, v. So of which you have been told uv is the functions of x, y, and z. X, y, and z. Now our solution, we have to differentiate all these arbitrary functions with respect to x and with respect to y. So the first step, we differentiate the whole function with respect to x. So this part, partial u, we differentiate with respect to x. So if we differentiate this part with respect to x, we get 1 plus 0, plus if we differentiate any letter, arbitrary letter by respect to x, we get b partial z, partial z, partial x. Then next, we differentiate this other part with respect to x. So we differentiate with respect to v with respect to x. We get, if we differentiate this one with respect to x, it will only affect the x part. So we get 2x plus 0 minus 2z partial z partial x. Now the second, this is differentiating partially with respect to x. Next, we differentiate partially with respect to y. So if we differentiate this point with respect to y, it will be 0 plus 1 plus, if we differentiate with respect to y, we get partial z partial y. Then this other part, we have partial v of y, we get 0 plus 2y minus 2z partial z partial y. Correct. Now our next step is replacing these partials with the initials here. Now we get partial u will be 1 plus partial z partial x will be q. Then plus partial v will be 2x plus it will be minus 2z partial x will be p, is equivalent to 0. Then we have the second one, partial with respect to y, partial u will be 1 plus, if we replace partial z partial y will be q here. So plus q, then plus partial of the function of a partial of u of v will be, if you replace here 2y minus 2z, then partial z partial y, or partial z partial y will be q. So this is q, which is equivalent to 0. Now we take this one, we take this point. At this point, we take this one across the equal sign, this one across the equal sign, and this other one in equation 2 across the equal sign. So let us make this one our equation 1, this one our equation 2. We take this one across the equal sign, then this one across the equal sign. So in equation 1, if you take this one across the equal sign, we get partial of arbitrary over partial of u 1 plus p is equivalent to minus partial of the full function over partial of v 2x minus 2zp. Now we divide both sides by partial partial v partial v. So this one, then we divide this other side by 1 plus p. So this one, so here we remain with partial the arbitrary function over partial of u over partial of arbitrary function over partial of v is equivalent to minus 2x minus 2zp over 1 plus q. Make this one our equation 3. Now we go next. Partial over partial u 1 plus q, then plus partial u partial the function of a partial v 2y minus 2z q. So is equals to 0, equal to 0. So if we take this one across the equal side, we get partial of the equation partial u 1 plus q is equivalent to negative partial of this arbitrary function over partial of v 2y minus 2z q. Now we divide both sides. This one function over v arbitrary function over v. So this one will cancel. Then we divide both sides by 1 plus q, 1 plus q. So this one will cancel. So we remain with partial of the function of u, partial of the function of partial u, v is equivalent to 2 negative 2y, negative because of this one, 2y minus 2zq over 1 plus q. So this is our equation 6. So now equate equation 5 and 6. So we get equation 5 and 6. We get negative 2x minus 2zp, negative 2x minus 2zp over 1 plus p is equivalent to negative 2y minus 2zq over 1 plus q. So this is our equation 5, this is our equation 6. Now, so if we equate this one, this sign will cancel with this one because of the equal sign. Now we cross multiply this one and this one. We get 2x minus 2zp multiplied by 1 plus q is equivalent to 2y minus 2zq multiplied by 1 plus q. Then you expand. We expand, we get, we multiply this one by this one, you get 2x. Multiply this one by this one, you get 2x. Then this one by this one, you get plus 2x cubed. Then this one by this one, you get minus 2zp. This one by this one, you get minus 2zqp. Is equivalent to this other side. this one and this one, we get 2y plus this one and this one, we get 2y cubed. This one and this one, we get minus 2z cubed. This one and this one, we get minus 2z cubed. 2z cubed. No, this one is this one was p. This one was p. This one was p, not q. This one was p. Now this one is p. 2z q p q, like that one. Now after reaching this point, we get to see that 2 is common all through. So if we simplify this 2, we remain with x plus xq minus zp minus zpq is equivalent to y plus yq minus zq minus zpq. Now this is our equation. Now if you get this one, if you take this one across this side, it will be plus. Then this one plus this one will cancel. This one will cancel. Then we have we will remain with. Then we take x across the equal side. We get x minus y is equivalent to, take this other y cube. This is y cube. Y cube minus z cube be minus x cube minus z minus will be plus z p. Now we regroup. We get x y minus y is equivalent to. I think this is where the mistake came from. We multiply 2y plus q. You get 2y q instead of 2y plus times p. So it is 2yp. So it will be yp here. Yp. So this one will be yp. So it will be yp. So we regroup. So this is yp, then plus zp minus zq minus xq. Then we factor out the common. So we have is equals to p y plus z. Then we have minus q z plus x minus y, and that is your correct answer. So we have solved the PDE by eliminating the arbitrary function. So this is the best method. I hope you have understood. Subscribe to my channel, then give me a like and comment. Thank you.